Hi guys, we're going to try just doing a video today and probably Wednesday as well and see how that works and maybe be able to transition into live streaming next week. We'll just kind of see. I hope it's going well for you. Let me know if you have any questions. Okay, so hopefully today won't take very long and tomorrow you can work on some problems. Okay, but today we're going to look at what's called the trapezoid rule. And we want to use this trapezoid rule to integrate some functions that we already know how to do just so that we can compare answers. But the trapezoid rule is used for functions that we can't integrate as easily other ways. Okay, so it's really just an approximation. But today, the ones that we do, we would be able to integrate other ways. We just want to be able to do some comparisons. Okay, so let's go ahead and go over to the Elmo. Now, these notes should be on Google Classroom, so you can either follow along with them or do your own, but know that they are there for your access. Okay, so the trapezoid rule has to do with, believe it or not, trapezoids. Okay, so let's say we have this graph, okay, and these should be equally spaced. I know they're not, but we have equally spaced intervals, and we can draw a trapezoid by taking the right endpoint of an interval and its y value and the y value of the x endpoint of the interval and connect with a straight line. And then we have our x-axis is another side of it. And then we have our bases or the parallel sides here. So note we do have a trapezoid here. Okay, and then we do that again. You draw another trapezoid, and you draw another trapezoid, okay, and another one. Okay, and so you can tell that it does model, at least in this function, a pretty good approximation. And to get an even better approximation, all we'd have to do is go in and split these intervals in half. And so then we could get even closer and closer and closer. Okay, and so the more intervals you have, the closer we will get to our actual answer. So we would say in this case, n approaches infinity. Okay, if we add up our trapezoids together. Okay, so let me go ahead and give you the trapezoid rule formula and try to explain where it comes from. Okay, so if we have our function f of x and we're trying to integrate it from a to b, okay, using the trapezoid rule, it is approximately equal to, and I'm going to run into my graph here, so I'm going to skip down a step, okay, b minus a over 2n, okay, and we'll talk about where that comes from in just a second, times f of x naught plus 2 of x sub 1 plus 2 of x sub 2 plus, okay, keep on going till our next to last term, which is f of x sub n minus 1, I still ran out of room, sorry, plus f of x sub n. Okay, so all the way to the end. Now, notice on the first one and the last one, the numbers in front are ones, okay, and we'll explain why in just a second. Everything else in between has 2. Okay. So that's one side note to get. Okay. Now, where does this all come from? Can you remind me what the area of a trapezoid is? Well, hopefully it went something like this. b1 plus b2 times the height over 2. Okay, so we add our two bases together and multiply by the height and divide by 2. Okay. Now, if we say this is a and this is b, if we want to get our height, okay, and the height is the distance between the two parallel sides or the two bases, this b minus a will give us that height. Okay, and notice that here. So here is your height, b minus a, okay, and we have the n intervals, okay, and then this 2 comes from the formula up here. Okay, so b minus a over n actually is your height. Okay, because this b minus a is the same all the way across. We've just divided it by n. Okay. Now, what about these parts? Okay. Well, we add our two bases together, right? And we're going to do that here, and then here, and here repeatedly. Okay. Well, how many times is this left base ever counted in a trapezoid? Okay. Well, it only happens in this first trapezoid. Okay. And then over here, this one is only counted in your last trapezoid. Now these f of x's are y values, right? So this is f of x naught, or xn, and this is f of x naught. Okay, so that's why there's only a 1 here. They're only included in one trapezoid. But what about all these others? Okay. So if we look at this one here, it's the right base of this first trapezoid, but when we go draw our second trapezoid, it's the left base. So it actually gets counted twice. So that happens to all of these in between. So that's why there's a 2 here and 1 here. Okay, so hopefully that makes somewhat a little bit of sense. Okay. So our job is just to find out what b and a are. Okay, they will give us n, and again, the more n, the higher the n is, the better this approximation is. Okay. 4 will be a pretty common one to use because that's taking your interval and cutting it in half and then cutting it in half again. Okay, and even 8 is a good one to use because then all you have to do is cut those 4 intervals in half as well. Okay, so all we have to do is b minus a over 2n, so that'll be pretty basic, and then we just have to go find the y values of these. Okay, and so it's just a lot of plugging in is what this is. What we are not doing is any type of integration. We don't use our power rule or substitution or anything. Okay, so this is just all algebra or plugging in at this point. Okay, so let's do an example. And believe it or not, we are going to start with a trig function, which I know is your favorite. Okay, so if we take the integral from 0 to pi of sine x dx. Now, we should know how to integrate this, and let's take a minute to do so. Okay, if we use our chart, whatever, this is negative cosine of x. Okay, and we go from 0 to pi. So we get negative cosine of pi minus a negative cosine, so that will become a plus, cosine of 0. So we get negative. And from your chart, or just remember this pi is to the left, so your x value would be negative 1. And the cosine of 0 is 1. Okay, so we have negative times negative 1 is positive 1, and 1 plus 1 is 2. So from regular integration, we know our answer is 2. Okay, but let's see using the trapezoid rule what we get. Okay. Now, again, the trapezoid rule is not useful for these as much because we know how to do this in a fairly simple way. The trapezoid rule is for those that are harder to do, okay, but we're just going to get good at it using these. First thing we have to do is look at our interval, okay, and we are going from 0 to pi. And again, they will tell you how many intervals to split it up into, okay, and so this time they tell us to do it into 4. They'll give you this number, n is 4, okay. Now we also need a and b, so this is a and this is b. And it says we have to have 4 equal intervals, okay? So all I do is cut this interval in half. And so halfway between 0 and pi is pi over 2. So here I have 2 intervals, so I need to cut it in half again, okay? So cut each interval in half. So this gives us pi over 4 and 3 pi over 4. So right now, hopefully you see that we have interval 1, 2, 3, and 4. Okay, that is stuff you have to do. Okay. Now let's just use our formula. It says if we're going to do this, we take b minus a. Okay, so pi minus 0 over 2n. So now we have 2 times 4. Okay, so that's that outside. And then we have to take it times our y values that we had up here. Okay, so now f of x naught. Okay, So we're talking about this. This is x naught, that left hand. Okay, so all we do is plug in x naught. Okay, so we take sine of 0. Okay, and we only want one of those is what our formula said. Okay. But then for our next one, we want 2 of those because our formula said we need 2 of those because it counts twice. Okay, so x. So this was our first one, and now this is our second one. So we have 2 times the sine of pi over 4. Okay, and we still want to do 2 of the next one, sine of pi over 2. Okay. And then we still want to do 2 times the sine of 3 pi over 4. Okay. But on this last one, because it's the endpoint, or it only gets counted once, we only want it one time. So sine of pi. Okay. Now you can put that all in your calculator. We can use our trig chart, whatever works for you. Okay. And no, you're not going to have a lot of trig. It's just a fairly simple one to look at. Okay, so this becomes pi over 8 if we simplify. Sine of 0 is 0. Okay. Sine of pi over 4, that's your 45 degrees. So it's root 2 over 2. Okay. Sine of 1/2 is just 1. Okay. Sorry. Let's see. So we're here at 0, pi over 4, 1/2. Sine of 3 pi over 4, that's 45 degrees over in that second quadrant. And so it's also root 2 over 2. And then sine of pi is 0. Okay. So now we have pi over 8. Okay. And we have, what do we have? So the zeros go out. And then we have 4 root 2 over 2, which is just 2 root 2 plus 2. And we could plug that in our calculator and see how close it is to 2. Okay, so pi divided by 8 times 2 root 2 plus 2. And yes, it would have been okay if you'd used your calculator from the get-go. Okay, but we get 1.896. Okay, so for an approximation, that's not bad at all. Okay, it is less than, well, pretty much just 1/10 away from our actual answer. And that was using only 4 intervals, okay? Or n is 4. Now, let's try it again and see n equal 8. Okay, so what did we say would happen when we had more intervals? Okay, well, we said that we would have an even closer approximation. Okay, so all we have to do now is, here we had 4 intervals. Now we just need to cut those in half. Okay, so I'm going to use that same chart. I'll use a highlighter, I guess. And I'm going to cut all these in half. Okay. And so we get pi over 8. And then this would be, let's see, that's 1 pi over 8. This would be 2 pi over 8. This is 3 pi over 8. 4 pi over 8. Next one would be 5 pi over 8. 6 pi over 8. And 7 pi over 8. Okay. So let's do the same thing. Now this outside will be pi minus 0 over 2 times 8 this time. Okay. And we have sine of 0 plus 2 sine of pi over 8. We're going to hit all the intervals up above. Okay. Plus 2 times the sine of pi over 4 plus 2 times the sine of 3 pi over 8 plus 2 times the sine of pi over 2 plus 2 times the sine of 5 pi over 8 plus 2 times the sine of 3 pi over 4 plus 2 times the sine of 7 pi over 8, and finally plus the sine of pi. Okay. Now, if you wanted to, you would be more than able to take these that we had already done and make that 1.896. Okay, but so I think what I'm going to do is just go ahead and put that in my calculator, and let's see what we go. Make sure you are in radians because that does have the pi in there. Okay, so that would be the only issue. Make sure you're in radians, go to mode, radians, okay, equals, and then get out of it. Okay, so I'm going to take sine of 0 plus 2 times the sine of pi over 8. I guess I didn't need that. Parenthesis. 2 times the sine of pi over 8 plus 2 times the sine of pi over 4 plus 2 times the sine of 3 pi over 8 plus 2 times the sine of pi over 2 plus 2 times the sine of 5 pi over 8 plus 2 times the sine of 3 pi over 4 plus 2 times the sine of 7 pi over 8 plus sine of pi. Now this one is harder than the previous one because pi over 8s are not something we know. You have to use a double angle formula. And I just got an error. Let's see, maybe. Okay, so I got, we're going to hope this is good, 10.0547-ish. Okay, so now I need to take it times pi, divide by 16. Okay, and we get 1.974. So we are only about 3/100ths of the way away just by going one more interval in. Okay, so hopefully that makes sense. Let's try it with a couple more. Okay, and we'll call it good for today. Okay, so let's take the function of from 0 to 2 of x cubed dx. Okay, get that where you can see it. Okay. Now this is one we know how to do as well, right? It's just x to the 4th over 4, and then we plug in 2 and we plug in 0. And we, I thought I did that somewhere. I'm not sure where it is. Okay, but all you have to do is plug that in and we know how to do that. Okay, and they just want us to find n as 4. Okay. So let's look at that in a minute. That's x to the 4th over 4 from 0 to 2 if we use normal integration. So we'd have 2 to the 4th over 4 minus 0 to the 4th over 4. So our actual answer is 4. Let's see how close we can get to that. Okay. So again, this is not what we would usually do. It's just we're using these for practice. Okay, so it tells us to go from 0 to 2. It tells us that we need 4 intervals. So cut it in half once, which is 1. Cut it in half again, and we have a half and 3 halves. 1.5 is fine. Okay. Now, b minus a, so 2 minus 0 over 2n. So again, they gave us the n, which is 4. Okay. Times, now we start plugging our y's in. Okay, and again, we only want one of these. So 0 to the 3rd plus 2. Okay, that was from the formula. Now we plug in 1/2 to the 3rd, because that's what our function says, plus 2 times 1 to the 3rd, plus 2 times 3/2 to the 3rd. And then when we get to our last one, we only use a 1. So 2 to the 3rd. Okay. So now we just simplify. This is 2/8, which is 1/4. Okay. 0 cubed is just 0. 1/2 cubed is 1/8. Okay. Times 2/8, so we just get a 4th. I said that wrong, I'm sorry. 1/8 times 2, so we get a 4th. Okay. 1 cubed is 1, so times 2 is 2. 3 cubed is 27, 2 cubed is 8, so we get 7/8 times 2, so that ends up giving us 27/4 okay, plus 8. So if we put those together, I see that this is 28/4, which is, what, 7? So we have 7, 9, 16. I messed up somewhere, didn't I? Okay. Sorry, a plus 2 is 10. This becomes 7, so we get 17 times a fourth, which is 17 fourths, which is 4.25. Okay, so pretty good approximation, only 0.25 off. How do we get a better approximation? Well, we just split these intervals in half, and so it would have n as 8. Okay, so that's the name of the game. And let's do one more. Okay, and then we'll call it good for today. Again, as I do these videos, if they get a little long, then please take a break. Okay. I know it's hard to just kind of watch, so you do it however you need to. I would suggest taking a break every 15 minutes or so. I should have mentioned that earlier, but you do what you need to be able to pay attention. Okay. Now this one we could also integrate fairly easily by hand, okay, but I'm not going to take that time right now. Okay, let's look at, we have 1 to 3, and we have n is 4, so we want to cut this in half. So 1 to 3 cut in half is 2, and so this would be 3 halves, and this would be 5 halves. Okay, so off we go. B minus A, so 3 minus 1 over 2, and then our n is 4. And remember, we start off with one of these, so we have 4 minus 1 squared. But all the others except the last one have a 2 in front. So 2 times 4 minus our next one, which is 3 halves squared, plus 2 times 4 minus 2 squared, plus 2 times 4 minus 5 halves squared. But now we're only at the end, so we only need one of those, 4 minus 3 squared. And now it's just a simplification game. 3 minus 1 is 2. 2 over 8 is 1/4. Okay. 4 minus 1 squared would be 3. Okay. Make sure I'm moving along right here. Okay. Plus 2 times 4 minus 9/4. Okay. Plus 2 times 0. Plus 2 times 4 minus 25/4, plus 4 minus 9. And I have that squared in the wrong place. Sorry. Okay. So we have 1/4 times, let's see, that goes away. Oh, I think I'm going to be lazy and put that in my calculator. Hopefully that's okay with you. So 3 plus 2, 4 minus 9 divided by 4, plus 2 times 4 minus 25/4, it's minus 5. And of course I messed up again. And that gave us -3. Okay, if you put that all in your calculator. So 1/4 times -3 is -3/4. Okay. You could always check that that's close using Wolfram Alpha. I worked this out somewhere. Let me see what it is. 12 minus. Okay. Well, I forgot what it is, but I'm fairly confident that is good. So we'll call that good today. Tomorrow I have 4 problems for you to try, and they'll be like this. Okay, so I will post that tomorrow. I hope you have a great day. If you have any questions, please let me know. We can discuss it by email or always Zoom if you need help with that. So let me know if you have any questions or suggestions. Talk to you later.